All right, so the question before us is, what does the dot product actually tell us geometrically? It was pretty easy to compute algebraically. The formula is very straightforward, but what's really going on here? Because it seems like there's got to be something, some meaning attached to this dot product. Otherwise, what's the point? And so in order to answer that question, I need to review a math formula that you may have forgotten. It's called the law of cosines. And the law of cosines is actually a generalization of the Pythagorean theorem. So the Pythagorean theorem is a special case of the law of cosines. And so here's the setup. So I've got a triangle, and I'm going to label my sides with little a, little b, little c. And then the opposite angle of little a, the opposite angle is big A, big B, and big C, vice versa. Okay, so the law of cosine says in that case, then you get the following three formulas. And there's three because it depends on sort of which sides you want to isolate. So for example, a squared, the length of a squared is the length of b squared plus the length of c squared. You've heard that minus 2 times the length of b, length of c, cosine of a. And there's always a cosine here. It's the cosine is the opposite angle of this guy. And then the other pieces here you can see are the other side. So if this is A, then you know there's going to be a BC minus BC cosine of A. If this is B, you're going to have an AC minus 2AC cosine B, so on and so forth. Once you see the law of cosines, it's really not that hard to remember it. Just as long as you know one version, you can figure out the others. And then, of course, think about it. When one of these angles here is 90 degrees, then the cosine drops out, leaving you with just this part, which is the Pythagorean theorem. So I need that law, so let's go ahead now and draw a picture together. So all I want to do is pick out two non-zero vectors, A and B. And so there they are. I've drawn them for you. And I'm interested in figuring out what this vector is, and I'm going to ask you, if you can, to please pause the video and if you need to look back, but see if you can figure out what this vector is in terms of A and B. Hopefully you remember that this is exactly the vector A minus B. So once we know that, then we can apply the law of cosines. The angle that we're interested in is this theta, and so that means that the side, the length that we're interested in is this A minus B. And so this sort of tells you which version of the law of cosines to apply. We want to talk about length, so we're going to say length of A minus B, length of A, length of B, so on and so forth. But if we just write down, I'll switch back to blue. If we just write down the law of cosines, we come up with the length of A minus B squared. We know is going to be the length of the other two squared, so length of A squared plus the length of B squared minus 2 length A, length B, cosine of theta. All right, great. But now think about from today's lecture, what did we learn about length squared? There's a way to interpret length squared as something we're interested in. Well, length squared is just the dot product, right? And that's good because so far there's no dot product in this picture, it seems, but there actually is. We know that all of these length squareds can be interpreted as dot products. I want to focus on this one right here. So we know that A minus B, the length of A minus B squared is actually A minus B dot A minus B. That's that side. I'm just going to copy the other side and drag it along here. Whoops, not cut. Don't want to do that. Let's paste it back. And then we're going to, let's erase the equal sign, and we'll paste it back here. There it goes. Oh, we barely squeezed it in. Very good. Okay. Now we learned with our rules for dot products that you can distribute this out. You can quite literally FOIL this out exactly the way that you think you should. And so when you do that, you end up with, you end up with A dot A. I'm going to go ahead and write that as length of A squared. Then you end up with a minus, look here, minus B dot A, and then you're going to end up with a minus A dot B. So there's your inside and outside. So I'm going to get a minus 2 times the vector A dot the vector B. I'll put those together. And then I'm going to get a minus B dot a minus B. So that's going to be plus B dot B, or if you want, length of B squared equals. And we'd better slide this over so we have a little more room. And then we should be able to paste. Oh, yeah, look at that. We got the double equals. There we go. We'll hide them together. Okay. Now you can see the magic here. This is really cool. These are going to cancel. The length B squareds are going to cancel. And all of a sudden, things are becoming clear. I've got minus 2 times A dot B equals negative 2 times the length of A, length of B times cosine theta. Cancel the negative 2's, and all of a sudden we can conclude, we can say, therefore, A dot B is precisely length A, length B, cosine theta. All right, so let's go ahead and break this video here. I don't want to get too long. And then we'll come back in the next video and figure out, okay, great, we have this formula, but what does that actually tell us? And it turns out it tells us some very useful information.